The National Electrical Code, or NEC, provides guidelines for electrical safety. Wire color codes are essential for identifying different conductors in electrical systems. Understanding these codes is crucial for safe and correct wiring practices. For a 120/240 volt single-phase system, the typical color code is black for the hot wire, red for the second hot wire in a 240 volt circuit, white for the neutral conductor, and green or bare copper for the ground conductor. For a 277/480 volt three-phase system, the color code typically uses brown, orange, and yellow for the three hot wires. Blue can be used as the fourth hot wire in a high-leg delta system. Gray is the preferred color for the neutral conductor, and green or bare copper is used for the ground conductor. For 600 volt systems, the color code can vary, but common colors include red, orange, blue, yellow, and brown for the hot wires. Green or bare copper remains the standard for the ground conductor. For 1000 volt systems, common colors are black, yellow, and orange, with green or bare copper for ground. For 2000 volt systems, common colors are black, red, and blue, with green or bare copper for ground. It is important to note that while these are common practices, local codes and specific applications may require different color coding schemes. Always consult the relevant electrical codes and standards for your specific project. Now let's explore why wire colors are not explicitly listed in the NEC. The NEC focuses primarily on electrical safety standards rather than specifying particular materials or components. There are several reasons for this. Firstly, variability in materials and manufacturing. Wire colors can vary significantly based on the insulation material used, the manufacturer, and even the production run. Specifying exact colors in the NEC would be impractical due to this variability. Secondly, the evolution of technology. The electrical industry is constantly evolving with new materials, techniques, and technologies. Including wire colors in the NEC would necessitate frequent updates to keep pace with these advancements. Thirdly, consistency with other standards. The NEC aims to align with other established electrical standards such as the National Electrical Safety Code, or NESC, and Underwriters Laboratories, or UL, Standard UL 580. These standards also address wire color coding. Maintaining consistency across these standards is important to prevent confusion and ensure uniformity in electrical practices. Fourthly, flexibility for code interpretations. By omitting specific wire color requirements, the NEC allows for flexibility in how different jurisdictions and applications interpret and enforce the code. This flexibility enables local authorities to adapt the code to meet their specific needs and industry practices. In summary, the NEC prioritizes electrical safety and performance standards over specific material specifications like wire color. The wire color code is defined under other standards, and leaving it out of the NEC allows for adaptability and consistency within the broader electrical industry. For example, UL 580 is a standard for industrial control panels, and it includes requirements for wire colors. Similarly, the NESC covers electrical safety for utility systems, including guidelines for wire identification. These standards complement the NEC and provide more specific guidance on wire color coding for particular applications. When working with electrical systems, it is crucial to consult not only the NEC but also any other relevant standards and local codes. This ensures that you are following the correct practices for your specific situation and complying with all applicable regulations. Remember that the primary goal of any electrical code is to ensure safety. Following established wire color codes helps to prevent accidents and facilitates troubleshooting and maintenance of electrical systems. Always de-energize circuits before working on them, and if you are not qualified to perform electrical work, consult a licensed electrician. Additional information to enhance understanding could include a deeper dive into specific applications and how wire colors are used in those contexts. For example, in residential wiring, the use of white for neutral and green for ground is nearly universal. However, in industrial settings, different color schemes may be used, particularly in control panels and machinery. Understanding these nuances is important for anyone working with electrical systems in various environments. Let's consider some examples of how wire colors are applied in different scenarios. In a typical residential 120-volt circuit, the black wire carries the current from the power source to the load, such as a light fixture or an outlet. The white wire, the neutral conductor, provides the return path for the current. The green or bare copper wire is the ground conductor, which provides a safe path for fault current in case of a short circuit. In a 240-volt circuit, such as one used for an electric dryer or range, there are two hot wires, typically black and red. These wires each carry 120 volts, and the voltage between them is 240 volts. The white wire still serves as the neutral, and the green or bare copper wire is the ground. In a three-phase system, such as those found in commercial and industrial buildings, there are three hot wires, which are typically brown, orange, and yellow in a 480-volt system, or black, red, and blue in a 208-volt system. The grey wire is used as the neutral, and the green or bare copper wire is the ground. It is important to note that in some older installations, different color codes may have been used. For example, in some older homes, the neutral wire may be black instead of white. This is why it is crucial to always test wires before working on them, even if they appear to be color-coded correctly. A voltage tester can be used to verify which wires are hot, neutral, and ground. In addition to the standard color codes, there are also specific requirements for identifying conductors in certain situations. For example, the NEC requires that the grounded conductor, or neutral, be identified by a continuous white or grey covering. The grounding conductor must be identified by a continuous green covering or be bare. These requirements help to ensure that these critical conductors are easily identifiable. There are also rules for re-identifying conductors. For example, if you need to use a wire for a different purpose than its original color code indicates, you can re-identify it using color tape or other means. However, it is important to follow the NEC guidelines for re-identification to avoid confusion. For example, you cannot re-identify a green wire to be a hot wire. The green wire must always be used for grounding purposes. Similarly, you cannot re-identify a white or grey wire to be a hot wire unless it is permanently re-identified at both ends and used only for switch loops. Switch loops are commonly used in lighting circuits where the switch is located on the neutral side of the circuit. When working with electrical systems, it is also important to be aware of the potential hazards. Electricity can be dangerous, and it is essential to take precautions to protect yourself from electric shock. Always de-energize circuits before working on them and use insulated tools and equipment. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not qualified to perform electrical work, consult a licensed electrician. Working with electricity requires knowledge, skill, and attention to detail. By understanding the NEC wire color codes and following safe work practices, you can help to ensure that electrical systems are installed and maintained safely and correctly. Remember to always consult the latest edition of the NEC and any other relevant standards and local codes for the most up-to-date information. The NEC is updated every 3 years, so it is important to stay current with the latest changes. Furthermore, consider the practical implications of these color codes in real-world scenarios. Imagine troubleshooting a complex electrical panel. Without consistent color coding, identifying the correct circuit and its purpose would be significantly more challenging and time-consuming. The standardization provided by these codes allows electricians to quickly and accurately diagnose and resolve issues, reducing downtime and potential hazards. Another important aspect is the role of wire color coding in preventing accidental connections. By adhering to the standard color schemes, the likelihood of connecting a hot wire to a neutral or ground is greatly reduced. Such errors can lead to short circuits, equipment damage, and even fires. Therefore, the seemingly simple practice of using the correct wire colors plays a crucial role in maintaining electrical safety. Think about the training and education of electricians. A significant portion of their training involves learning and understanding wire color codes. This knowledge is fundamental to their ability to perform their job safely and effectively. By consistently applying these codes, electricians create a common language that facilitates communication and collaboration among professionals. Consider the impact of globalization on electrical standards. As products and equipment are manufactured and used internationally, the need for harmonization of electrical standards becomes increasingly important. While there may be some regional variations in wire color coding, the underlying principles remain the same. Ensuring safety and preventing confusion are paramount. In addition to the standard color codes for power conductors, there are also specific colors used for control wiring in industrial applications. These colors are often specified in standards such as UL 508A, and they help to identify different types of control signals such as start, stop, and emergency stop. The use of these standardized colors simplifies the design, installation, and maintenance of control systems. When selecting wire for a particular application, it is important to consider not only the color but also the other characteristics of the wire, such as its gauge, insulation type, and temperature rating. The wire must be suitable for the voltage and current it will carry, as well as the environmental conditions in which it will be used. Using the wrong type of wire can create a safety hazard. It's also worth noting that while the NEC does not mandate specific wire colors, it does require that all conductors be clearly identifiable. This can be achieved through the use of color coding, marking tape, or other means. The key is to ensure that anyone working on the electrical system can easily identify the purpose of each conductor. Let's also discuss some common misconceptions about wire color codes. One common misconception is that the color code is the only thing that matters. While color coding is important, it is not a substitute for proper testing and verification. Always use a voltage tester to confirm that a wire is de-energized before working on it, regardless of its color. Another misconception is that all countries use the same wire color codes. While there is some degree of harmonization, there are still regional differences. It is important to be aware of the local codes and standards when working in a different country. Finally, it is important to remember that wire color codes are just one aspect of electrical safety. There are many other factors that contribute to a safe electrical system, such as proper grounding, overcurrent protection, and insulation. By paying attention to all of these factors, you can help to ensure that electrical systems are installed and maintained safely and correctly. The importance of documentation in electrical work cannot be overstated. Accurate and up-to-date drawings and schematics are essential for troubleshooting and maintenance. These documents should clearly indicate the wire colors and their corresponding functions. Without proper documentation, it can be difficult to determine the purpose of each conductor, especially in complex systems. In addition to drawings and schematics, it is also important to label wires and components clearly. Labels should be durable and easy to read, and they should be placed in a location where they are easily visible. Proper labeling can save time and effort during troubleshooting and maintenance, and it can also help to prevent errors. The advancement in technology has brought about new methods for wire identification, such as the use of wire markers that can be printed on demand. These markers can be customized to include wire numbers, circuit designations, and other information. The use of these markers can greatly improve the accuracy and efficiency of wire identification. As technology continues to evolve, we can expect to see even more innovative solutions for wire identification and management. These solutions will help to make electrical systems safer, more reliable, and easier to maintain. Remember, the ultimate goal of wire color coding and identification is to ensure safety and prevent accidents. By following the established codes and practices, and by staying up to date with the latest technologies, we can create a safer environment for everyone. It is beneficial to understand the historical context of wire color coding. The practice of using different colors to identify conductors dates back to the early days of electrical wiring. The initial purpose was simply to differentiate between the hot, neutral, and ground wires. Over time, as electrical systems became more complex, the need for more standardized color codes became apparent. The development of the NEC and other standards played a crucial role in establishing these standardized codes. While the specific colors used may have varied over time, the underlying principle of using color to identify conductors has remained constant. Consider the impact of wire color coding on the efficiency of electrical installations. When electricians can quickly and easily identify the different conductors, they can complete the installation more quickly and accurately. This can save time and money, and it can also reduce the risk of errors. In addition to the direct benefits of wire color coding, there are also indirect benefits. For example, when electrical systems are properly installed and maintained, they are less likely to experience failures. This can reduce downtime and improve the reliability of equipment. It can also extend the lifespan of electrical components. The concept of wire color coding also extends to other types of cables, such as data cables and communication cables. While the specific colors used may be different, the underlying principle of using color to identify conductors remains the same. In these types of cables, color coding is used to identify the different pairs of wires which are used to transmit data or voice signals. For example, in Ethernet cables, the 8 wires are typically color-coded with 4 different colors, each of which is paired with a white stripe. This color coding helps to ensure that the wires are properly connected, which is essential for reliable data transmission. Furthermore, always remember the importance of continuous education and training in the field of electrical work. The NEC and other standards are constantly evolving, and it is important for electricians to stay up to date with the latest changes. There are many ways to continue your education, such as attending seminars, taking online courses, and reading industry publications. By staying informed, you can ensure that you are providing the best possible service to your clients and that you are adhering to the highest standards of safety. The use of wire color coding is not just a matter of following the rules, it is a matter of professional responsibility. As electricians, we have a responsibility to ensure that the electrical systems we install and maintain are safe and reliable. By adhering to the established codes and practices, we can help to protect the public from the hazards of electricity. So, the next time you are working with electrical wires, take a moment to appreciate the importance of wire color coding. It is a simple but essential practice that helps to ensure the safety and reliability of electrical systems. Always remember safety first, and always follow the rules.